We are back. So if you've never been, you can actually go to imdb.com right now and play around or download the mobile app. And it's just big database of a lot of TV shows and movies and actors and the like. But what indeed is nice is you can download some of that data. And that's what I've done in advance. And what we've done is we wrote some Python code to convert some of the flat file databases that they let you download. And we converted it into a SQL database with 6 tables. So not just one, but 6 that ultimately are these here. And let me just help you wrap your minds around what this picture is, which is an entity relationship diagram, which is just to say each of these boxes on the screen represents a table, and each of the arrows or edges represents some kind of relationship across the tables. Because up until now, the only data we had were those 3 columns in the favorites table. But what gets really useful about SQL databases, just like a Google spreadsheet or an Excel file, is you can have multiple sheets, or in a database, multiple tables. And so what we're about to see is that in this IMDb database for TV shows, there's going to be a dedicated table for all the people in the TV business. There's going to be a dedicated table for all of the TV shows that are in their database as of right now. There's going to be a dedicated table for writers in that industry, for the ratings of shows, for the genres to which shows belong, comedy and the like. And then lastly, there's going to be this table which somehow associates people with the TV shows that they star in, and vice versa. And so let's consider first what this looks like in code. And we'll see that it's going to overwhelm intentionally at first. But I'm going to do this. I'm going to go back to my terminal window. And during the break, I downloaded from the course's website a file called shows.db, which we made in advance for you. And if I type ls, I'll see all of my favorites files from before, the CSV, the DB, and the Python file. But now there's shows.db. So I'm going to go ahead in my full screen terminal window here. I'm not using actual tabs or code files now. I'm going to run SQLite 3 on the file called shows.db. And I'm just going to see this version information here. Let me clear my screen and run the one command I ran earlier to show us the schema of the favorites database. Now we'll see the schema for the shows database. And there's a lot going on here, but let me scroll back up to the very top, the beginning, and we see this here. So when I run .schema, we see a dump, really, of all of the SQL create table commands that were run in order to create this database for you. And one of those tables is called genres, and another people, ratings, shows, stars, and so forth. And the columns therein, even though it's formatted a little more prettily than the automatically generated create table statement for favorites, whereby we have one column per line of output here. In the, for instance, people table, there's going to be an ID column, like a unique identifier, like a Harvard ID, a Yale ID, or the like, a name column, a birth year, and then some other stuff. If I scroll down to shows, every show in the world is going to have a unique ID as well, a title, of course, the year in which it debuted, and the total number of episodes as of the time we downloaded the data. And then what else is there? Some of these are a little less obvious, like ratings here. So ratings don't have an ID column, but they have a show ID column and a rating, like a 5-point scale or 10-point scale or the like, and then the total number of votes that were collected to contribute to that rating. IMDb allows people to upvote and downvote shows and movies and the like. And then similarly is genre structured. There's a show ID, and then there's a genre, which is going to be like an English word like comedy or drama or something else. And then what else? Let's go a little further at the bottom here for stars and writers. If we go to the very bottom here, stars and writers are similarly structured too. They have a show ID and a person ID. So show and person. And then this writers table has a show ID and a person ID. And there's a whole lot of other words that we'll come to in just a moment. But what is this code hinting at? Well, if I go back to the picture from earlier here, you'll see that this picture captures the relationships among these various tables. So for instance, if we focus on shows for just a moment, a show, again, has a unique ID, a title, a year in which it debuted, and a total number of episodes. If you want to figure out what genre or genres a show belongs to, because some shows are just comedies, some shows are just dramas, but some shows are arguably comedies and dramas depending on the episode or the like. So you can imagine wanting to associate 2 or 3 or even more genres with a show. This line here in this second table allows us to do that. Every row in the genres table, we'll see, has two items, a show ID, which relates to the ID of a show. And that's why these lines literally line up with that specific column name. And a genre, which is going to be like quote unquote comedy, quote unquote drama, or something else. Now, with that said, design question, why have we deliberately not just gotten rid of this genres table and made our lives simpler by just adding a genre column to this shows table? And again, a table is just like a sheet with rows and columns. At the moment, shows only have 4 columns, ID, title, year, episodes. Why not just add a 5th column called genre and put the show's genre there? Any intuition here? Why not just keep things simple? Like, yeah, and back. Exactly. If you add a 5th column here and call it genre, then you have to pick a genre specifically. You have to put in that cell, presumably, comedy, or drama, or musical, or something else. Now, you could write multiple words in the cell, but generally speaking, that would be sloppy, bad design. Like every cell, just like in a spreadsheet, should really have one value. It might have multiple words, but it shouldn't be like a weirdly comma-separated list of multiple things. It should just be in a different cell in that case. So if you instead were to design this with just a single column called genre, you're imposing what a computer scientist would call a one-to-one relationship. Every show has one genre, and that's not necessarily a good thing. Or strictly speaking, it would be a many-to-one because the same genre could belong to multiple shows, but each show could only have one genre in that case. What a relational database allows you to do, and relational is indeed the operative word, it allows you to factor out some of your information and then have maybe one show here in one row. But then in this genres table, you could have one row for that one show genre, or you could have 2 rows in the genres table for comedy and for drama. Or if it has a 3rd genre, you could just add another row here. So you still have one row for the show itself with all the juiciest details, but a variable number of rows by having this relationship with another table. Meanwhile, ratings work the same way, at least in this case. A show has ID, title, year, and episodes. But if you want to figure out its rating, you have to kind of follow the arrow here, so to speak, and look up the corresponding show ID in this table, find the rating of that show, and the total number of ratings. So that's been factored out too, for better or for worse. Now let's consider people. People have just 3 columns, ID, name, and birth. But there's no mention of the TV show in which people have starred, or the TV shows that a person has written. Well, why is that? Well, if you just had a 4th column here called show, well, you would have to decide what show is that person in. And no one could ever act again in another show because there's no room to store the data. But if someone, of course, a popular actor can star in multiple shows, well, we could have one ID for that person, one name, one birth year, obviously. Like there's only one Steve Carell as an actor in the world of people. But Steve Carell in this example could have his person ID, whatever his Harvard ID equivalent, Yale ID equivalent is, appear in multiple rows in this table so that it can be associated with multiple shows. And this allows you to create what's called a one-to-many relationship, or technically it's bidirectional. It's a many-to-many relationship. Why? Well, one show can certainly have multiple people in it and multiple people writing for it, just in the real world. But conversely, one person could certainly act in multiple shows or write multiple shows. So this is what you get with relational databases. You put your sort of canonical data for people in one place, for shows in another place, and then you use these additional tables to relate one thing to another. So we won't dwell on the pictures. That's just if you sort of can wrap your mind around the data set better that way. That's one way of thinking about it. But recall that the code we just saw for the schema, again, escalated quickly. Like there's a lot of keywords I haven't mentioned yet, but some of these are perhaps familiar. They're capitalized differently here, but integer is on the list here. Null is on the list, albeit technically not null. So let's tease apart some of these keywords and consider what they're actually doing for your database, because now we're exploring features that do not exist in the world of spreadsheets alone. So it turns out in a SQL database, specifically SQLite, which is the version of SQL we use in CS50 and which is commonly used for for things like mobile applications nowadays. It's like a lightweight version of SQL. It's when you aren't trying to run Twitter and have billions and billions of rows necessarily. You've got hundreds, thousands, tens of thousands, maybe even a few million, but not crazy numbers, crazy amounts of data. In the world of SQLite specifically, there's these 5 data types. So just like in C, we had int and char and the like, in SQL, we have these. Blob, which is kind of funny, but it just means binary large object. So it's like a binary data type, zeros and ones that aren't necessarily fitting into the other categories. Integer, which of course is an integer as we know it. Numeric, which is kind of a catch-all for numbers that are formatted specially. So like a date would be like year, 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 dash month, month, dash day, day. And this is actually a wonderful thing. Depending on the country you're from, you might think your date system in your country is great or it's horrible. The US system is horrible because we have month, day, and then year, which is impossible to sort. It is the wrong way objectively to store data, and yet here we are using this at scale. Other countries have gotten this better. Numeric and SQL itself standardizes that stuff. So it doesn't matter what country you're from, you're storing your data in this particular way, for instance. Times are standardized in other types of numeric data as well. Real is synonymous with float, so something with a decimal point and some number of digits thereafter. And then text is just for strings and the like. With other even fancier databases like MySQL, PostgreSQL, Oracle, and other products you might have heard of, there's even more data types where you have to make even finer grained decisions. But for SQLite, it's indeed pretty lightweight, and you or we just have to decide the data types for each column in a table. But there's these additional constraints in the world of SQL. You can additionally say that cells in this column may or may not be null. So if you want to protect yourself from yourself so you don't screw up and insert a null, that is a blank value, you can explicitly design a table to have a column that cannot be null. And so in fact, someone came up during the break to ask me about my having manually inserted SQL, quote unquote, SQL into our favorites database. You might recall that I kind of cheated. I just inserted SQL, quote unquote, and 50ville, the name of a new problem, quote unquote. But what did I not insert into the database? A timestamp. And I could have put like the current day and time a few minutes ago, but I didn't. And that's fine if it's acceptable to you and the product you're building. But I could have prevented that. If we had defined the table to have a timestamp column that isn't just text, but it's text that's not null, SQL would have complained and would not have let me complete that insertion. So there's these kinds of built-in defenses that you don't necessarily get with a spreadsheet alone. And unique means exactly that. If you want to make sure that every row in that column is unique, maybe for email addresses, or in the US, social security numbers, or anything that you want to make sure you don't have 2 versions of, you can specify that the column is unique. And there's other such constraints as well.